So power set. So definition, let A be any set. Then its power set, and its power set, I'm defining this, is the following. So the notation that we use is like it's not a capital P, but it's like a script P or something like that. Okay. So the power set of A, by definition, this is the following set. It's a set, the collection of all B's such that B is a subset of A. In other words, it's a set whose elements are all subsets of A. So in words, is the set of all subsets of A. Okay? So for example, let me give you some examples right now. Let's say that the example with A equals the empty set. Let's compute its power set. Then let's compute the power set of the set 1, 2, 3. And then let's compute the power set of the set 1, 2, 3, 4. And then hopefully you will see something interesting happening here. All right, let's see. For them, and by the way, okay, so the empty set. What's the power set of the empty set? What's the power set of the empty set? So power set of A here is the power set of the empty set. What is this? The empty set. Why? Are you saying the empty set has no subset? That's all. So it's not an empty set. It has an element. It's the set containing the empty set. Remember, it's just all possible subsets of this guy. Now, what are the subsets of the empty set? Just the empty set. Remember, we just proved the empty set is a subset of everybody, right? So in other words, power set is never empty. Doesn't make sense to say that the power set of something is empty. The empty set is always an element in there. Because the empty set shows up as a subset everywhere. Do you understand this? We proved it. Okay. For number 2. So in particular, notice that this is not empty. Okay? I want you to notice that. It's not the empty set. Okay, so number 2, what would be the power set of A? We have to make all possible subsets. If you want, let me do here, I guess, 1B. Let's do it with one element. So what would be the power set of the set containing the element 1? What is this? You have to list all subsets. What are all subsets?
The empty set and 1.
The empty set and the set containing 1. You have to be careful. The elements inside the power set are sets, not just elements. Okay, so you have to put the little curly braces. Do you understand this? Okay, good. So in general, in fact, the power set of A always contains the following elements. So a subset of the power set is this set. In other words, what I'm saying here is that every element here is an element in this set. So every time that you write the power set of something, you will always have at least 2 guys, the empty set and the whole set itself. Now, there could be more stuff, okay? Keep in mind that when A is the empty set, it's not 2, it's just 1, because then if A is empty, these 2 things, this is just the same as this. Remember, repetition is not important, okay? So when you're listing the power set of a set, always understand that you need to have the empty set, the whole thing, but then there could be other stuff, okay? So let's practice how to find that other stuff. Like in this case, it was the empty set and the whole thing, because there's nothing more to do, okay? But let's take a look at this one. So I know for sure that my empty set, the empty set has to be in the list, and the whole thing has to be in the list. Yes, because they are all subsets of A. Now you have to find all other subsets. So what are all other subsets that we can write? Set containing 1. Okay, the set containing 1 and 2.
Set 2 and 3.
Okay, let's try to keep it algorithmically or systematically. Why? Because now I give you a cell with 10 elements, you're gonna go crazy trying to see. In fact, you're gonna have 1,024 elements inside that set. So if you don't have a plan on how to write them down systematically, like on truth tables, we had a systematic way of writing our combinations of true and false, so we know that we're not missing anything. Okay? So let's try to establish a systematic way. And for example, in the one that I'm gonna explain you, this one will come in last. So I'm gonna erase it. So here is what you can do. We start with the empty set because that's there regardless of what's happening. Now here's what we're gonna do. We're gonna go by length, by amount of elements. Okay? Yes, by amount. Should I go by amount of elements? Or the first guy and then yeah, I'm going to go by length. So elements of length 1, what are they?
1, 2.
Would be 1, would be 2, and would be 3. I wonder if I wanna tell you this. Yeah, okay, by length. So 1, 2, 3. Now that's all possibilities for length 1, right? Now let's exhaust all possibilities of length 2. And to find them, here's what you do. We're gonna start with the first element, and we're going to combine this guy with everybody else. Once we're done, we go to the next one and repeat. Okay? So now we can do 1 and 2, 1 and 3. That's it, we cannot do more. So now go to the next and repeat. You don't have to go back to 1 because we already have that one. Okay? So now the only new length 2 element that comes in is 2 and 3. We are done with that. Now we go to the next one. What's the next length? 3. Well, in this case, when you go to length 3, it's just everybody together, right? And we're done. So if you follow this is only for a finite set, of course. When you follow this process, at the end, you will always end up with the last guy, which is the whole set. Okay? And then you're done. So, do you understand how we build this one? So let's count. How many elements do we have here? 8. Okay. So do number 3. Write them down. Get the feeling in your hands. Write the elements in number 3. Let me take attendance. Daniela Áviles, Andy Brito, Raúl Campos, Brian Cruz, Miguel Díaz, Brian Echevarría, Anthony Fuentes, Ian German, Talía González, Carlos González, Sebastián González, Alejandro Iscaray, Alfredo Llanes, Edwin Mendieta, Mario Núñez, Leonardo Quevedo, Michael Valdez. All right. Did you write them down? How many elements did you get? 16? Yeah. All right, so let's see. Let's do it. So again, following this process, my first guy will be length 0, right? So which one has length 0? When I say length, I mean number of elements, okay? So what will be the length 0 case? The empty set, right? That's the one that has no elements. Now we move to length 1. So we're going to stop when we get to length 4, right? Because that's the length for the number of elements of our set. Okay, so length 1, I have 1, 2, 3, and 4. Everybody okay with this? Now let's go ahead and let's move to length 2. Okay, I'm gonna do it in rows. Okay. All right. So I need to do 1 with 2. Then we can do 1 with 3. Then we can do 1 with 4. And we're done with 1. Go to 2 and repeat. That will be 2 with 3. 2 with 4. We're done with 2. Now go to 3 and repeat. That will be 3 with 4. There's no need to look back because 3 with 2 we already have it. 3 with 1 we already have it. You understand this? You just have to look forward. And then done with length 2. Yes? Now we need to go to length 3. What are the length 3? So I will be 1, 2, 3. Okay. So now, here is a little bit more tricky. And my advice to you is the following. Fix the first two, okay? And then change the rest and find all possibilities. And then once you're done, then you fix the first and the last and find all possibilities. And then you fix the two and the second and the last. You understand what I'm saying? So you want to write all 1, 2 something. Once you're done with that, you want to write all 1, 3 something. Yes? And then all 2, 3 something. Does that make sense? Okay. So let's see. 1, 2, 3. Then 1, 2, 4. And that's it. I cannot write anything else with 1 and 2. Now let's write everything that we can with 1 and 3. Okay? So, because I fixed the 1 and the 2, now I'm going to fix the 1 and the 3. Remember, you always look forward. That's why you have a way to order the elements is good. There's no need to put a 2 in there because I already have that set. So the only thing that we should look forward to is 4. 1, 3, 4. I already did everything I could with 1. Now I'm going to move to 2 and repeat. Let's see. 2 and 1, no, but now we do the pair 2, 3. And that's only 2, 3, 4. Yes? And you cannot go to 3 because if you go to 3, you're forced to go back to make a length 3 because you only have 3 and 4 available. So to make a length 3 set, you will have to use 1 and 2, but those were already used over here. Okay? So that's length 3. And then what do we need? So length 4, which is the whole thing. And we close it up. All right, so let's make sure that we have everything here. So 1, 2, 3, 1, 2, 4, then 1, 3, 4, and 2, 3, 4. Yes. So let's count. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So let's write this down. Notice that in this case, the cardinality of the power set equals 16. In the case before, the cardinality of the power set equal 8. And then I guess over here, what was the cardinality of the power set? It's 1. And no, 2. And over here, the cardinality of the power set was 1. Right? Let's try to see if we find a pattern. Okay? For example, hopefully you realize that this is 2 to the 0. This is 2 to the 1. This is 2 cubed. This is 2 to the 4. And it turns out that 4, what is 4? The number of elements in A. So this is 2 to the cardinality of A. Same thing's happening here. You see, this is 2 to the cardinality of A because A has 3 elements. That's 2 to the cardinality of A. A has 1 element. And this is 2 to the cardinality of A because A here is the empty set, so it has no elements. Yes? The point is that this is always the case. Now, when we talk about counting, we're going to see why. We're going to prove this later on. Okay? But right now, let's take it as a theorem because it's going to help you out. At least you know when you're done listing subsets. Okay? So theorem, we'll prove this later when we discuss counting. But right now, let's say if the cardinality of a set A is n, then the cardinality of its power set is 2 to the cardinality of A. In other words, it's 2 to the n. So by saying this, I'm saying if a set is finite, then the cardinality of its power set is 2 to the number of elements of the set. Okay? So a result from here is corollary. So if a set A is finite with cardinality equals to n, so with n elements, then there will be in the homework you have questions like this. Number 1, what's the number of subsets of A?
Yeah, he asks you for proper and improper substance.
Yeah, so what's the number of subsets of A? That's just the cardinality of the power set. Remember, the power set is just all subsets together, right? The collection of all subsets. So That's just 2 to the n. Okay? Now, what's the number of proper subsets? Why?
Because the last one is the same.
Very good. So, if you want to count how many proper subsets a set has, all you have to do is the number of subsets, but remember, this is also counting the whole thing inside, the whole set A. Just take that one out. That's 1 that you have to remove. So that's 2 to the n minus 1. So how many proper subsets this guy has? Well, it has 15 because it's everything that we have here. Just remove this one. Remember, proper means that you are not allowing the whole set to be there. Okay? So you only the smaller guys. So it's always minus 1. So that's your formula, so you can do those little homework problems that you have. Okay? So number of subsets is just 2 to the n, where n is the number of elements. Number of proper subsets is 2 to the n minus 1. Okay? Now you know why minus 1. You're just removing the whole thing, like the entire set. We okay with this? Okay, be careful with the. All right, good. So then I guess let's do a little proof involving power sets. So another theorem, or I guess example. Prove the following. So prove that the power set of A is a subset of the power set of B if and only if A is a subset of B. So let's prove that the power set of A of A and B are sets, some sets. Okay? And let's prove that the power set of A is a subset of the power set of B if and only if A is a subset of B. Now remember, if and only if this is a biconditional. What do you need to do to argue a biconditional? You need to prove 2 directions. Okay? So recall to prove the statement of the form P if and only if Q, what we do is we prove 2 things. First, we prove that P implies Q, and then second, we also prove that Q implies P. Because remember, P if and only if Q is equivalent to P implies Q and Q implies P. Okay? So every time that you want to prove a biconditional statement, this is what you do. You need to prove one direction, but then you also need to prove the other. Okay? So in other words, this proof is going to have 2 parts. First, we need to prove that if the power set of A is a subset of the power set of B, then that means that A has to be a subset of B. Okay? And then we're going to prove the other direction that says if A is a subset of B, then the power set of A is inside, is a subset of the power set of B. Okay? We got to prove those 2 statements. All right, so solution. So first, we're going to do this direction. Okay? So that means we want to prove that if the power set of A is a subset of the power set of B, then A is a subset of B. We're proving this. And then we need to prove the other direction. Do you understand this? All right. Again, this is an if-then. How do we prove if-then? Assume P, prove Q, right? So we start by saying, assume, again, here it is understood that, let A and B be 2 sets. This is at the very beginning. Now we're going to assume this part, we're going to prove the other one. So assume the power set of A is a subset of the power set of B. Okay? So we have this. When we're going to use it, I don't know. We will see. Okay? Now, my advice to you is, we assume this, we need to prove this. Now, it's always good to write what is it that you want. And that way, you're going to get an idea of what you need to do to get there. So, this, you put it in a corner. I'm putting it here, but this really you should put it in a corner where nobody sees it. This is just for you. Okay? So, what do we want? What do we want to show? So, we want to show that A is a subset of B, which is equivalent to say what? That if X is in A, then X is in B. Yes? So we want to end up with the statement of this form being true. This is what I want. So now when you look at what you want, this already tells you what should be your first line. So because this is what you want, how should we begin? So we want to prove that that's true now. So how should we begin? Assume P, prove Q. It's the same idea over and over again. So now my next line is, so remember, this is in a corner, nobody sees this part that is in red. Assume the power set of A is also the power set of B. Now I'm going to let X be an element in A. Because what I want to show is that if X is in A, then X is in B, right? So you just start with an element in A. So now my next line would be, let X be an element in A. Now, the point is that I want to do some work, and eventually I want to end up with this. How? We will see. Okay? Of course, the idea is that somehow we want to use this assumption to be able to get to this other side. Okay? Now let's see. Let X be in A. I know I want to fill in details, and I want to end up with X being in B. Let's see if we can do it. All right. What can we do here? What do you think? All we have at our disposal is our knowledge of the power sets, how they relate. So if you want to use this, right, that's the only thing that we have, then somehow we need to be able to go up to this level. Now, what sort of elements do we have inside these guys? How do they look like? They are sets, right? And what do I have here? Element. So the first thing that we need to do is we need to make a set out of this. So how can you make a set out of this? Let's put curly braces around, right? So if X is in A, so let X be in A. So then I will consider the set containing X. Where is this guy? In the power set of A. X is in A, but the set containing A, containing X, is now a subset of A. Yes? So let me write this. This is now a subset of A. And what do we use for this? What's the justification for this step? We basically use definition of subset, right? I'm going to put the reasoning, I'm going to put it here. The reason why this line implies this one is because of the definition of subset. Do you understand this? Because X is in A, so this set is a subset of A. But now, if this is a subset of A, this is an element where? In the power set. Now, this tells me that this is an element in the power set of A. You have to be very careful. Notice how I'm switching from subset to element. You have to make sure that when it makes sense to do so. Okay? For example, if you write this, that doesn't make sense. If you're writing a computer program, the compiler is going to scream at you right here. It's not going to compile because it doesn't make sense. There is an element, but this, when you write this on the power set, it's expecting a set, not an element. Okay? So you have to be careful. All right. Now I managed to show that this element, this set is an element in the power set. Now we can use our assumption. If it's an element in the power set of A, what can we say now? It's also an element in the power set of B. That's our jump from A to B. Why? Because of subset, right? Every element here is supposed to be an element here, right? That's what it means. So now from here it follows. I'm going to take a couple more lines. So now from here we get that this means that the set containing X is an element in the power set of B. Why do we know this? Because by assumption, right? So this was the assumption. And assumption slash definition of subset, right? Because we're saying that the power set of A is a subset of the power set of B. That's our assumption. Okay, but now we can unwind. So if this is an element in the power set of B, what can you say about this set? It means that it's a subset of B, right? So then from here, it follows that then the set containing X is a subset of B. Here we use definition of power set, meaning that its elements are the subsets of B. So because this is an element, that means this guy is a subset. But now, if this is a subset of B, what does that mean about X itself? It has to be an element of B because it's a subset. Every element here is an element here, right? Then from here, we get that then X is an element of B. Here, what justification do we use for this? Definition of what? Subset. Definition of subset. So if you ignore all the in between, now we managed to show, assuming this, we show that if X is in A, then X is in B. You know, transitivity, we put all of this, and then X in A implies X is in B. Yes? So A is a subset of B. Did you understand this? Now let's do. Okay, do you see how to do it the other way around? How would you do it the other way? Let's say try it, and then on Wednesday we're going to. I'll do it. I mean, just I don't want to take more of your time. I'm like some minutes off. So the other way around would be assume. Let me just write what the other way around would be. So now you want to show that if A is a subset of B, then the power set of A must be a subset of the power set of B. Try to write this on your own, okay? As a whole. So do this as a home. Okay? Remember, you need to assume this, and then you want to prove this. So to prove this, what do? Start with an element in here, and then somehow argue that that element is also here. Along the way, you may need to use this information. Okay? Think about it and see how you can do it. On Wednesday, of course, we will discuss. Any questions? Okay, so again, here's your exam. I want you to pick it up so you can see what you did, because as I mentioned, there will be, I'm going to give you an extra credit for Friday. Now, for this extra credit, it's going to be done online, so you have to connect. It's going to be from 9. Actually, I should do it from 10 to 11, because that's the time of the class. Okay? So we're going to do it from 10 to 11. You have to connect. Yes?
I work on Fridays from 10 a.m. until.
Okay. Okay. Do you guys have class on Monday before our class? Is everybody free before our class on Monday? Yes or no? Yeah. Yes? Okay. So, well, you have to be here in school because then you need to come to class. Okay? So then let's do the following. Let's do it, or we can do it on Wednesday if you want. Are you free on Wednesday before our class? That way we get it out of the way. Okay, so then on Wednesday, just if you have a laptop, you bring it. If you don't have a laptop, you can go to the computer courtyard in building 2. Okay? Then what I'm gonna do is at 9 a.m., because I will be teaching here. So at 9 a.m., I'm going to open up the extra credit on my open map, and you will have, okay, 60 minutes. Okay, I'm gonna open it at 8:50 because so you have time to be here at 10, right? So it's gonna open up from 8:50 to 9:50. Okay, you will do it and then you come to class. Yes. Now you need to connect on the. You need to enter on the course. You know how to enter collaborate in here on Blackboard. Yes. Should I show you?
It's done, right?
Because I need to give you a code for you to open the exam. It's not just going to be automatically open for you. Okay, so you have to connect with me. I'll put it on the chat, you get it, and then you start working on the exam. Okay, so, yeah, let me stop this.
We done the virtual one, the virtual, right?